We've got. All right. Good afternoon, everyone. Welcome to this seminar. And it's really nice to see that we are many. There are other 30 people connected on Zoom. And it's a really great pleasure to have here with us Chris White from Blacklight University. And we had this opportunity because he came at use for a collaboration in an Horizon Europe project that's called Mediate. He will give a few words about the project as well during his presentation. But it's really a pleasure in any case to have the opportunity to work together and be here and listen to your talk. He's the head of the Center of Water, Environment and Public Health. He's an associate dean for postgraduate research in Strathclyde. Is an engineer as a background, but is spread across different disciplines, and I hope that we will have the opportunity to see these cross-cutting topics. And really thanks. And floor is yours. And please, I don't know, we'll take approximately an hour, something like that.
Yeah.
Let's see how it's going, but feel free. Thanks again.
Hope that's okay. I prefer to stand just because there's a bit more energy usually, but also then when I do stand, I like to I always walk around. So I just find that helps me a little bit. What I'm not so comfortable with is holding a microphone because I feel like I'm a singer or something. I'm definitely not a singer, and you don't want to hear me sing. So that's fine. There's a cursor on the thing. I don't think that's from mine. I think
that's mine.
Okay. Firstly, Macho, thank you very much for inviting me here today. Thanks for hosting me for yesterday and today. Very much appreciated, and thank you. And thank you for the introduction. I also just want to acknowledge, it's written quite small on here, but there's a number of acknowledgements on this that I've basically either asked or stolen material from various people to produce the slides that are here. So thanks to those that are here or might be online that are watching, that there's material that I've used to do this, including Natalia that's at the front here, which you have nicked a couple of your slides, so thank you. The topic I'm going to talk through is, as you probably would guess, given by what has been discussed already in the last sort of hour or so, is multi-hazards and the combinations of different natural hazards, how they interact, how that affects risk, and that within the backdrop of a changing climate. So the title I put together is multi-hazard risk. I've explained a little bit as to why these terms are interchangeable, but basically I've put every possible term I can think of into one title and hope that some of it sticks. I will get on to, is that going to work? Yes, okay. I will get on to the Mediate project as I get into the presentation. That's the project that we're working on together. But I think the majority of my talk here or seminar is around the concept and the idea of what multi-hazards are, why they're important, the challenges that are associated with multi-hazard thinking, and then some examples and progress that other people are making, what we're trying to do in the Mediate project. And perhaps then some challenges that I compose as to where we perhaps need to be sort of going next. First off, I will just say hello from Glasgow. I've lost count of the amount of people since I've been here in a day that have said, thanks for bringing the Scottish weather with you from Scotland to Italy. I'm really sorry. I didn't mean to bring this weather with me. This is a good day in Glasgow. Unfortunately, I came here expecting sun and drinking a glass of wine. Unfortunately, it's been pouring with rain. I'm really sorry if that's my fault. But I live in Glasgow. For those of you that are really good with accents, you'll know that I'm not Scottish. I'm very much English, really, with a good smashing of Australian in there as well. But I live in Scotland. I've been in Glasgow for nearly 7 years. I don't know if they fully accepted me as being Scottish, probably never will, but that's where I'm from, or at least that's where I'm based. At the University of Strathclyde, which is where I am, so Glasgow has kind of two big universities, the University of Glasgow and the University of Strathclyde. we're the sort of tougher city-based university. We're quite a technological engineering-focused university. And within our university, we have a number of different centres, and I'm very fortunate to look after this one, which I mentioned briefly in the little kind of discussion for some of us that we had earlier, which is the Centre for Water, Environment, Sustainability and Public Health. So in contrast, perhaps, to, say, the Charisma group, which is there's a good amount of, where there's kind of focused around particular topics, we're quite a diverse centre, but then that also has nice opportunities for working with colleagues that work in different areas. My area within there is climate impacts, climate resilience. I have I suppose, a sub-research group, which I call Engineering for Extremes, which is that combination of climate science and extreme events, knowledge, but bringing that into the engineering context. But together we form the Centre for Water, Environment, Sustainability and Public Health, and there's probably upwards to about 20 or so academics and 20 to 30 PhD students within that centre. I'm not going to talk much about Strathclyde. We can, if you want to know more about Strathclyde, I'm happy to talk more afterwards. Just to say that my centre, where I'm based, I'm a civil engineer, so I'm in the Department of Civil and Environmental Engineering. But as a faculty, so we have different setups. So as a faculty, we are the largest of the 4 faculties at Strathclyde. And we cover all of the engineering disciplines and architecture, so we're 8 in total. And I won't focus on, but my associate dean role that was mentioned right at the beginning, that's a faculty-wide role. So I have this kind of oversight role for PhD candidates at the faculty level, and we have about 600 or so PhD students within there. But I'm in the civil engineering one, and that's where my centre's based. I'm sorry, you've got to look at a photo. You've got to look at me and a photo of me. I need to change that slide. In terms of background, who I am, I come from the water side. So yes, I'm an engineer by background. For those of you that were here earlier, I went to Australia for a number of years. I went to meteorology, climatology, but my background is engineering, and I've come back to engineering. I have been there now for 10 years, but I look at weather and climate from a solutions-oriented perspective. But I do that with a good basis of good climate and weather knowledge and understanding. And in recent years, I've gone from perhaps being, let's say, flood and drought focused. So I'm always on the hazards, extreme events. That's my kind of core theme, I suppose. But I've gone more from that to more hazards in general and how they intersect with different portions of our society, hence the multi-hazard kind of way of thinking. I got into it actually through compound events. I'll explain a little bit about the difference perhaps between the two. But basically, if you can put these 2 parts together, it's water, flood, drought, and then the interaction with those and other hazards. That's kind of the core of what I do. Hence why I'm working on a couple of multi-hazard projects, including the immediate project, which I'm doing with Marcello and colleagues. Can you hear me okay, by the way? I keep on moving this around, I realise. Okay, thank you. So I suppose this part is probably a bit more seminar-esque, really. Less about me, thankfully, at this point, and more around what the definitions are, the context, really, to what multi-hazards are and why we're looking at them. An easy way, I think, of demonstrating what, let's say, I think we mean, and the reason I say I think we mean is that everyone does have a slightly different opinion, can look back at some recent events. I'm not going to spend too long on this, but recent events as to why we need to think about things in a slightly more joined up way than perhaps traditionally we have done. This is a slide from summer 2022, so not quite, but nearly two years ago. And this has, I'm based in the UK, so this has quite a UK focus. It was, of course, a European-wide heat wave. But for the UK, this was an important event. This was the first time we had 40 degrees in the UK. And we had a number of records broken, the highest number of any event of this type being broken at the same time in the UK. Now, heat waves are, yes, they're temperature-driven events, but there's a number of other factors that need to happen for an impact to be really severe from a heat wave. We've got to have dry soil, also dry conditions beforehand, as well as the peak temperature. You could also connect with, well, what's happening on the larger climate system that would produce such a warm air mass that will sit there for a period of time. So whilst we can look at it in the singular like this through records, there's also an understanding that it's not as simple as this. There are other parts to this. And in a changing climate, it's these sorts of events that we're starting to see more frequent. And of course, in the model projections and in the future, these are the sort of events that we will see more and more. So this is the context behind what I think the reason for looking at things less singularly, less siloed, but more in a joined up real world application. Again, this is Scotland specific now at this point. From natural hazards then come interesting or slightly different impacts. Scotland, as I've just joked, rains a lot. Well, that's not a joke, it's true. But Scotland is regarded as a water-rich country. It calls itself a hydro nation because it has good expertise in water, but it has a lot of water in which to utilize. But in recent years, water scarcity has started to become a significant problem in Scotland. And you wouldn't really associate that. SEPA is the national body for environment, so it's the government body for environment. You wouldn't think of Scotland being impacted by water shortages. But here is, again, an interesting point. What has caused the water shortage? Is it just simply not enough rain? It's partially that. There's also the management of water. I don't want to say mismanagement because that implies that someone's doing it. It's not mismanagement, it's just in the Scottish context, we probably manage water in a different way than we perhaps need to be in the future. So from a connected way of thinking, we need to think more around, well, what is the interplay between floods and drought? Or let's take away the hazard element. How we need to think more about rainfall, high and low. So in times of deficit, so in times of surplus, and therefore it becomes more of a water management question at that point. But behind there sits that interaction between more than one phenomena that will lead to an impact. And I think traditionally, we tend to think of something in the singular. It's easy for us to do. You mentioned earlier about construct in the Italian context of siloed disciplines. In many countries, it's the same. That's not from slightly different, but in the hazards way, the way that we quantify a flood, the way we quantify a drought, individual siloed, traditionally different disciplines. But the impact, if you were to trace it backwards from an impact, is more than that. This is another example here of let's say, what I've called a limitation of a single hazard thinking. This was in 2016. It was a crop failure event in France. What caused this event? It would be easy or simple to think, well, it didn't rain enough, or the water wasn't stored and managed well enough that then caused the crop failure. But of course, with a lot of things, it's far more complicated than that. It was actually a series of events or a sequence of events that led to the ultimate crop failure in 2016. It was a warm autumn and winter the year before, which is not so good for planting, followed by a very wet spring, which then washed out the crop and didn't allow it to grow when it should do. Either one of those in isolation may or may not have led to an impact, but the combination of the two led to the impact in 2016. But if you think about it singularly, you think about it as a single hazard or a single impact, you wouldn't capture that complexity. And then lastly, as an example, and again, this is from a couple of years ago, this is 2021. I focused a little bit here on the UK, but actually some of these storms impacted far wider than the UK did. This is a trio of storms, Dudley, Eunice, and Franklin, all impacted slightly different regions of the UK. Some of these were really significant. They didn't necessarily kill people at the time, but what they did do is cause significant damage. One of these, I forget which one it was, I think Eunice, had one of the highest impacts to forestry in the UK ever. It knocked out thousands and thousands of forestry trees. But one of the interesting parts of this was the recovery element is still dealing with one, then of course something else then happens. Again, if we think about things in single hazard way, we'll be preparing for one storm, or perhaps one direction of storm. The more traditional, in the UK, storms typically come from the Atlantic and come from the southwest. Some of these storms, though, didn't, and that's what caused some of the worst impacts. So the limitations of where we, let's say, traditionally think about events in a single way means we're not really capturing our true past exposure to some of these events. And I think more importantly, or as importantly, we're then not necessarily capturing how these may change in the future. And it's one thing to try and understand the mechanisms and the understanding of here and now, but I think we're all in the business of being more prepared, more resilient in a changing climate to what will happen in the future. So understanding or being able to model and quantify these interconnections will then, in theory, enable us to be more prepared for the future. I don't know whether I warned you, but I don't know if I warned anyone else. There are a few definition slides on here. And I'm not going to read this, and I don't really want you to read it either. It's more to make the point, and this has already been discussed today, that definitions are in part, I think, one of the things that's actually hampering our approach or holding back our approach in a multi-hazard sense. If we think about hazards singularly, that's one challenge enough, trying to break out of those disciplines. But also, and I can say this from the project that we're involved in, is that we also have different understanding of what some of these key things are. What is a hazard? That might seem really simple, what's a hazard? But actually it can mean slightly different things to different people. Multi-hazard, well, simply it's the combinations of all the hazards that could impact a place. But it doesn't necessarily talk to the interactions between them. It can do, but it doesn't absolutely have to. Compound events is more from a climate perspective, really does talk about the interactions, the mechanisms, the physics between some of these events. And you've got other examples of triggering, something that triggers something else. These terms, my point with showing this slide is definitions are both, they can help us to frame and understand things better, but also they can hamper and they can hold us back if we spend half of our time trying to redefine what we mean by this. So in a multi-hazard setting, if some of these say are interchangeable, the challenge is to simplify and not keep on adding. I think even in the Mediate project, and we're all doing, we all add more terms to redefine, tweak, and change. But really here, these definitions need to be refined, because ultimately what we're trying to do with multi-hazards is get to a point where we understand that the real world is interconnected and everything connects to something else. Taken from the compound event side, so compound events, say, is more of a traditionally climate type of discipline, maybe hydrological and climatological, I would say, which in the last 10 years or so has really tried to make inroads into quantifying some of these key interactions between hazards. It came up with this kind of, as a community, came up with these kind of 4 different types. I'm not here to say these are right or wrong. And you could argue that some of these are sort of the same, or there's others that are missed off here. I agree with all of those comments. But at least it provides us with something, a means of stratifying or cutting our way of thinking into something that's manageable. So on one hand, I'm advocating moving away from single hazard thinking into a multi-hazard thinking, and then straight away I'm then going from multi-hazard into something that we can use. But that's the reality. That's one of the challenges, actually, I think, that we face as a community, is to how do we still deal with things that are still simply are manageable. So this attempt, which has these kind of four definitions, preconditioned, multivariate, temporally, and spatially compounding, at least enables us to look at interactions from a mechanistic perspective. So, for example, I'll start with preconditioned. Now, preconditioned, to me, is a good hydrological type of phenomena. Something has to happen before something else can happen. In this case, so if you use the hydrology example, rain saturating a catchment in itself is not a hazard, just means it rains a lot and the catchment is wet. But then another rainfall event that falls on that wet catchment means you could then have a flood. That's preconditioning. So I'm quite familiar with that as a term when I think of it in that way. The majority of knowledge in this space in compound events is actually in the multivariate one. So I'm pointing to my screen here, like you can see what I'm pointing at. The upper right-hand one, sorry, is multivariate. And multivariate is simply two things that happen at the same time. They may or may not be interlinked physically, but probably more than not, they are. So the examples here is drought and heat, wind and heavy precipitation, storms, for example. Multivariate. So most of the joined up events get put into that multivariate bucket. The slightly more difficult ones, either conceptually and indeed difficult to model, are the temporal and the spatial. Temporal is a sequence between those three storms that I showed. That's a temporally compounding event. Series of impacts, but it's separated in time. The other one is spatial. You need something to happen in one place, something to happen in another place that then might cause an impact, maybe even somewhere else, but those combinations have to happen spatially. But I mentioned a minute ago that I'm already going from multi back to more sub-disciplines to make it even more complicated, because some of these aren't mutually exclusive. You can have some combinations that you could say, well, actually, that event is more of a multivariate event than a spatially compounding event. So I'm putting it there as more of a mechanism or a means in which to frame our thinking and help us, as opposed to being a strict, rigid, we have to follow this as a process. And this becomes really important, especially in that kind of spatial temporal component, when you look at the range of hazards that any one place or any society or sector could be impacted by. Hopefully you can see this slide, and some of you will have seen this from the paper that it's in from a few years ago. But this does a really nice job at looking at the temporal and spatial scales of the hazards themselves, not the interactions between them, but of the hazards themselves. So on one end of the scale, you've got things that happen really quickly, like an avalanche or a landslide. That's on the bottom left. Right up to drought, which is typically a longer term phenomena, volcanic eruptions and so forth. And then others that are either a bit more, either small scale in terms of space or long to short term scales in terms of time. But visually, this gives us an idea as to where these hazards might overlap. So climate change, you could put obviously behind all of this, really, if you want to, because climate change is exacerbating a lot of the phenomena or the drivers that create these hazards. But these overlaps, these interconnecting points, gives us an idea as to perhaps where we might need to look at pairings or joined up hazards to think, well, where would the impacts be? Conversely, of course, you could go from a social perspective and say, well, what is the most impact for your area, your sector, your dam, your electricity network? But from a science perspective, from a climate science perspective, this is a good starting point. And if we know then which hazards interact with each other or could interact with each other, I think is a better way to say it, then we can start to look at it slightly more from a risk perspective, which is you have a hazard. Now, a hazard will happen over some period of time, combined with another hazard, which will also happen over some period of time. One might trigger another, or one might just happen to co-occur. But then from that, you can then get into the exposure and the damage, and getting a little bit more into the risk space. But still behind here is that spatial and temporal question of how these hazards interact. Now, a question that we have still posed to ourselves in the Mediate project, and I will come on to what the Mediate project is in a minute, is, well, really, what's the benefit of going from single to multi-hazard? Tried in the last few slides to give an idea as to why I think we need to do it. Another way to demonstrate it, of course, is to put some numbers behind it, put some evidence there that says, well, actually, we need to be thinking about things in a joined up, interconnected way because, and back it up with evidence. This is a piece of work that was done by one of my students. It was published last year. I will caveat this by saying, before I describe what it is, this is a first pass study. It uses MDAT. Anyone that's used MDAT will know it's good on a global, large scale. It's not very good at the local scale, but it's indicative. It gives us an idea. It gives us somewhere in which to focus. Simply what we have done here is use the MDAT database and look at the records in there that says this event was caused by, this event was a flood, this event was a drought, this event was a heat wave. Simple counting type of process. But then within there are subcategories in MDAT. I don't know whether you've used MDAT in anger, but in there are subcategories that say things like associated hazard, associated disaster, I think actually is the term that's used. So in there is at least an indication that or some of those events co-occurred or were influenced by or followed on from some other event. They also put impacts in that same subcategory just to confuse things, which you had to sort of take away. But from a multi-hazard perspective, we found out that in the MDAT database, nearly 20% of the records that are in MDAT have some association, according to MDAT that is, of being linked to or more hazards. Now that makes it really interesting because straight away, if 20% of the total are in there are multi-hazard events or could be classified as multi-hazard events, then we've got something to work with. We've got something that we can say, well, of those, which ones are they associated with? And most importantly is, do they cause more or less damage or impact? So on what we've got here is a series of pie charts. We've got primary hazard, which is on the left-hand side, so primary hazard, going from drought, earthquake. The one I've just highlighted is temperature. So we've taken away the actual numbers of the records, but there's several hundred temperature-driven examples in MDAT. But what we've then done is say, of those, let's just say it's 500. Of those 500, 87% of them were classified as just being single hazard in MDAT. In other words, there was no association, no record of it being associated with anything else. But 13% of them could potentially be classed as multi-hazard because there's an association with heat and something else. We're not recording what's something else here. That comes later in the paper. But interesting, if you then go to the second column, so I'm just up here at the moment. Can I can do it. Yeah, okay, thank you. Sorry, I haven't got it. Okay. It's the same numbers, it's the same events. But when you then go from occurrence to loss, this is monetary loss, this is money. Instead of that 13% being 13% of occurrences, it's now those 13% equate to 66% of the financial losses. So disproportionately, assuming they're categorized correctly, those 13% of temperature plus something else events created 66% of the recorded losses under that temperature banner in MDAT. Likewise, fatalities, 36% from 13%. So again, with the caveat of knowing the limitations that do come with a database like MDAT, even on this example here, the assumption or what this interprets to be is multi-hazards in some hazards in particular have a much greater impact because there's combinations of more than one thing going on than if you just look at a single event, like just a heat wave and nothing else happening. It's the same when you look at storms, for example. 28% in this database say that the occurrence, the 28% of them are multi-hazard events as they are recorded, but they account for 70% of the financial losses. So to try and answer that why multi-hazard question, we can start to use things like this to give us information that at least demonstrates or starts to demonstrate why we need to be thinking about multi-hazards in a joined up way. Now, please.
Just a clarification on the previous slide. How are losses computed? I mean, what are those losses referring to? Like, is that case to buildings?
Insured losses. In MDAT, it's insured losses. Insurance losses, yeah. So, and it's in US dollars and normalized.
Okay.
Yeah. So there's anyone that's going to EGU, you can see me talk on this if you really wanted to for a full 8 minutes. Although I managed to talk on this one slide for 8 minutes, I think. So I'm probably not going to be able to say much more. But yeah, we use the same. We haven't adjusted or done anything with the data. We're simply extracting the information out if it qualifies as our event. Yeah, thanks. Now, alongside this kind of, let's say, growing recognition of, let's say, the need for interacting hazards and the need for more, a better understanding, I suppose, of these type of events, so too has the research community and the publications that are attached to those also grown. This is a study by Lou, who's one of my current PhD students. This is still in preparation, so it's not published yet. But she's doing a review of research in this space over the last 10 years. The reason for the last 10 years is in 2012, July 2012, was the publication of the IPCC's Special Report on Extremes. So that was the first time that compound events really came to the forefront in the scientific community, being sort of around in various terms. That was the first time we said, we really need to be thinking about things in a joined up way. And you can see, even just by numbers, these are just numbers of publications per year, the rapid growth over the last decade. And the colors just associate to where those studies are. So the research community is adding information all the time to this body of research, but it's focusing only on some areas. If you think back to that slide where I had the four typologies, the four types of compound events, temporal, spatial, multivariate, the vast majority of studies, this is from Lou's study as well, are in that multivariate space. They're looking at two things co-occurring at the same time. Why? Because that's the easiest and the most logical one to study. Temporal, spatial is tucked down at the bottom, preconditioned even worse. Very few studies. Many of you, by the way, are looking for where the research gap is. The research gap is down spatial. If you're in this space, spatial and temporal, very few studies done in there that connect these things together. But with that, with the growth of research, with the growth of understanding of this as a topic, the data, I just showed MDAT as an example, the data that isn't there to support it. I've purposely positioned that study, the MDAT study, as being high level and with some quite strong caveats. But what we really need to start recording, I think, at a national level, across country or globally, however we want to frame it, is a better understanding of how and when these hazards actually connect. It's one thing for someone to put in a database that a heat wave co-occurred with a drought, but really, without going back through the record, how true is that? And to what extent? And in what way did that interaction happen? We don't have that information. The databases that we have to hand do not allow for that. Equally, our definitions don't still really allow for it. These are the Hazard information profiles for UNDRR. I don't know whether anyone's looked at these. We're using these a little bit in the Mediate project. There's 300 definitions of hazards. If you want to know what a hazard is, here's 302 examples of it. In this first pass, and this is going to be changed a little bit, but in this first pass, there is no association of anything interconnected with anything else. So we don't really have the definitions. Comes back to that definition slide. What's a multi-hazard event? We don't have that information yet, really. We're getting there, but we don't have it. But even then, if you do have data, you do have the evidence, you do have the research questions and need, then of course, with that then comes an awful lot of complexity. This is from quite a well-known paper from nearly 7, 8 years or so ago now, which started to map interactions between hazards. But it's conceptually wanted to say, how can one thing affect another? And we're using this as a bit of a basis for some of the work that we're currently doing actually in the Mediate project, which is to think, well, which one could trigger something else? Which one could co-occur? It comes back to that slide, that spatial temporal, which two things could never really happen, or which one should we be focusing upon? But then to break that down, well, there's multiple approaches then as to how can we study, how can we understand that segregation that I showed of compound events of those 4 different types. That's one approach. We could just do simple rankings. Yeah, how often does one occur and how often does another occur? Perfectly valid. Maybe it misses some of the mechanisms behind it, but at least at one level, this is an approach. The other end of the scale, this is from a colleague who's just done it, generally you probably know, actually, Sylvia. So you know Sylvia Dan?
Yeah, she did a PhD here.
She did a PhD here. Okay, fine. You will know her then. Okay, so this is an approach from Sylvia. Brilliant piece of work. Really quite complicated, and that's fine. But what she has tried to do here is map the mechanisms. So on one hand, you've got something that doesn't really map mechanisms; it just maps occurrences, and another where it goes really complicated really quite quickly. And again, we've had those sort of discussions even here in the Media project in these last 2 days. So that's the picture that, as much as anything that I'm painting, is I think there's a clear need and want to go from single to multi-hazard thinking. But I think in some ways, the research community, the data, the evidence, the processes that we need to use, there's still a disconnect between those. Now, maybe it'll never get to the time where everything's perfect and there's one solution and everything works. But in the time that I have been working in this area, I did my PhD actually in joint probability back in, when did I finish? 2007, I finished my PhD. That wasn't classed as multi-hazards or compound events. Those terms didn't exist then. But now those terms do exist. There's too many of them, but they do exist. But the picture is there's still an awful lot of gaps and connections to be made in this interconnected way of thinking. I'm just going to have a drink just for myself. Oh, I will say, by the way, if you want to, as you did, yeah, if you want to stop and ask questions, and I'm making this quite a formal presentation, please do. Sorry. Now, my background, my interest is hazard. As an engineer, I understand risk. I understand the concepts of risk in the application of risk thinking. I wouldn't say that's my area. I'm not a risk person. I am more hazard, which is probably why if I was to draw a line, I would be slightly more on the hazard side than I would on the risk side. But I understand risk and I understand the need, of course, for it. So we're going to give you some more definitions just to really hammer home why we need definitions. The first one on here is the one you've seen before, which is multi-hazards. But there are some other subtle versions of this that then try to step across to moving from hazard thinking into a more of a risk impact application perspective. I'm not sure I agree with some of these. The multi-hazard risk as a term, I'm not quite sure I agree with that one. Multi-risk, well, that's just layering risk as opposed to layering hazards. But the bottom one here, I quite like because this is the one that I obviously then stole and used in the title of my seminar here today, which is multi-hazard or multi-risk. In other words, it's up to you to determine which one of these you want to use, but it refers simply to all of the above. And this is where I hope as a discipline or a sub-discipline or a connected discipline, perhaps, I hope we go, which is I don't want to keep on adding more and more definitions. If anything, I want more simplicity, as you might have noted in the last meeting. I want more simplicity in our approach to this, because if we keep on adding more and more complexity, it will just provide more challenges. But the importance of doing this, I think, and maybe this slide here talks as much to the why multi-hazard thinking or multi-risk thinking than anything else than perhaps that I've showed, is it doesn't actually matter what I think, it doesn't matter what any of us here think, but when you start seeing these sorts of calls and terms from the IPCC to the Sendai framework to the UNDRR, World Bank, EU security strategy, pick any one of these, they're all saying something similar, which is we need to have a better handle on how things happen in the real world, how things are really interconnected. What is the chain from start to finish? Yes, it's great that we can have people that are experts in their field, but this is the real world element that we're talking about here. So if there's ever a reason, or if you ever want a justification as to why multi-hazard thinking, it's this. But then with that complexity, as I mentioned earlier, then that was just on the hazard side. When you bring in the extra layer of, well, if you translate that across to risk, interacting risk, compound risk, multiple terms again. This piece of work here is a really interesting approach to how do we separate out these various things to deal with them. But ultimately, I would prefer a bit more of that approach that we showed earlier, which is multi-hazard, multi-risk, and that combination. Because if we try and separate these things out, we are, at this point, I think, really starting to kind of split hairs. I don't know how that term translates perhaps so well, but we're trying to categorize things down to really small pieces. To me, the approach here demonstrates just simply the need to bring in both hazard and risk end to end, not bring in additional complexity. Why is it important? If we think about this in the framing of climate change, which is the second part of my title of this talk, is because future risk, future impacts, it's not just about the hazard. Risk, of course, that's one part of the whole risk cycle or risk circle, or however you want to frame risk. And climate change, of course, can influence any one of those. It's not just the hazard. It can impact our individual, our vulnerabilities, our exposure. It can influence our systems or how we calculate things. So at various points can climate change impact these. So I think again, the need to understand hazards and the interconnections between hazards and whether those interconnections will change is one part of this broader something. Again, we don't need perhaps too many reasons as to why we know this is important. I'm probably, what's the word? Preaching to the converted? Is that the... Okay, so when you're telling something to people that they already obviously will know that, okay, so, sorry. This, again, IPCC sort of language, the reasons for concern, those areas we should be focusing on. I've already shown that list of who is calling for complex hazards to be better understood. Extreme weather events, as you know, a big component of you here are dealing with extreme weather events. There should be no question as to why we need perhaps to be doing this. But those complexities are real. And I'm not trying to boil it down to something simple, because multi-hazards, compound hazards, how they change space and time, whether we have the evidence and the data, and whether we understand the impacts, and you can wrap that all in a nice kind of risk bubble, we're presenting quite a complex picture. and especially when you add the context or the backdrop there. Oh, look, I've got the warming stripes in there. I've forgotten that was in. Yeah, you can wrap that up then in a reason as to why we're doing some of the work we're trying to do in the media project, which I'll get to. For me, the complexities of multi-hazard thinking or multi-risk thinking, multi-hazard risk thinking, depending on your interest and your area. For me, these are 3 or 4 areas that I think, or perhaps I'm interested in and I'm working on and I think we need to know more on. For me, one of the first ones is understanding the dynamics, perhaps a more process-based, physics-based between both the hazards but also risk, and as what causes these things and how will these change in the future. So that's very scientific, very physics, very process-driven. Added to that then are these dependencies, these interconnections between our sectors, different regions, time and space, and indeed the hazards. And this is probably these 2 that I have spent most of my time in my career or most of my interest in. These are in some ways not answerable questions, but we can start to make an attempt and demonstrate how we can do so. This one, I like this. I don't know who this person is, but it's a lovely quote that just says, "We haven't yet provided the answer. We don't know how to do it." I actually don't think that's quite true. And as you'll see in the next couple of slides, hopefully we'll demonstrate where we're starting to do it. But it's a good point to say the modeling and the process isn't quite there yet, but we need it. And then, of course, then you've got the management side of it. With this information, what do you do? What can you do with it? How, importantly, how can risk be better managed? How can you build more resilience if you have this information? Again, that's the sort of questions that we've been grappling with in the Mediate project. These, to me, capture, very high level, but these capture the things that I'm most interested in and we're trying to achieve in some of the projects. And we'll do it for time.
Yeah, perfect.
Okay. So I've mentioned the Mediate project a few times, and I'm sure, have you presented the Mediate project before?
No, not to those.
I'm sure Marcello would love to give you a presentation on the Mediate project in the very near future. But for those that haven't heard much about the Mediate project, it's a 3-year Horizon Europe funded project led by a consortium of 18 partners led by Norsar in Oslo in Norway. And as you can see by the map, these are our partners that are involved in here, of which use is a core partner, EU Centre, which you know well, just up the road, or another partner, RENA, just down the way here as well, from the Italian side. In this project, what we're trying to do is tackle some of those questions that I've been pointing to, or background I've been sort of highlighting so far, which is how do we get a grip on multi-hazards as a first pass? And then how can that be fed into a risk system such that better decisions can be made? I would say that's quite an objective to set in any one project. But such is the way of Horizon Europe projects that you often have to say you're going to promise everything. This is being recorded, isn't it? We will achieve this really, really well in the, just remember that, in the Mediate project. Within the approach, and I think this is very similar to a lot of European projects, the approach of Mediate is, we can't, of course, do everything. Far from it. What we can do is have test cases, case studies, or test beds, as we've called them here, to demonstrate how we can do some of the things that we want to do, take some of the methods that exist, develop new methods, and try and demonstrate and prove that we can do this end-to-end chain, starting with hazard and ending with, hopefully, a better decision, simplifying things. But that's ultimately the aim of the project. Our 4 test beds, our 4 test case areas. We've got Nice, not so far, of course, from here. Essex, which is an area just outside London. and it's called Osterbru, but it's Mullathing, which is a region in Iceland, so on Western Iceland, and then Oslo as our case studies. All contrasting areas, all different, all are at risk, let's say, to a range of different hazards. So we're using different geographical areas, different drivers, different metrics, different impacts, different ranges here. The Mullathing one area in Iceland is very small communities with very specific hazards. Essex is more heat waves and flooding, for example. So we can do contrasts and areas across here, and then demonstrate how these would then be expanded across Europe. As a project, this is kind of our setup. The area that myself, Marcello, and others are interested in are these kind of first 2 or 3 parts, which is the multi-hazard interaction, trying to quantify the interactions between various hazards, how some of the impacts then might cascade, so knock-on effects, I think is probably the easiest way to do it, and then how we can capture that in some kind of meaningful, simple to understand statistics. Is this third one actually the reason why I'm here primarily this week is to look at that third part. But a lot of the work that we have been doing so far in the work package that I'm leading which is the multi-hazard one, is to quantify those multi-hazards. Don't look at the detail on here, but simply is to say that we've been taking kind of a 4-step process in which to do so. I think most of our time in this work package has been this, which is pulling together the methods of how do you quantify across a range of different interactions between hazards in a consistent, coherent way with the knowledge of data limitations and the needs and wants of our local partners and stakeholders that want something that either may or may not be achievable. So managing all of that is in that process. And we again took that approach, if you remember back a few slides, to that kind of multivariate compound event thinking to help us frame our hazards and which ones we're going to focus on. So that was this process is to, let's frame our thinking or our approach. Then we do the part, which is to do some mapping of hazard interactions. This is the one that we submitted yesterday, so we're all quite relieved and happy and looking forward to a beer later, which is the quantification of the hazard interactions. Then goes into, this is where Rena have been involved and leading, which is the the impacts from those events. And then lastly, which is the one we're still working on, which is then the communication part. So this kind of 4-step, but the majority of work really has been in those kind of first 3 up to this point. Across our 4 test beds, so remember we've got Oslo, Nice, Essex, and Mullathing in Iceland, is, again, we can't do everything. We've got 4 places. So we worked with our stakeholders to say, in those areas, which combinations of hazards are the most important? Which are the ones you either have no knowledge of and want better knowledge of, or which do you know, either anecdotally or proven through evidence, are the hazard interactions of most interest to you? So through a workshop process and a kind of an iterative discussion, we came up with 3, we call them priority hazard pairs for each of the test beds. And these fit across a range of different types of compound events or multi-hazards. So in Oslo, for example, so the colours probably aren't translating so well here, but in Oslo we're particularly interested in compound flooding, so coastal and riverine flooding, interacting, which actually was there, I did my PhD, funny enough, that was where I got into this as a topic. But also they have a particular interest in floods or heavy precipitation and quick flow, which is a more geological hazard, but it's triggered in part by heavy rainfall leading to it, but also likewise landslide. So they were the 3 that they wanted us to be looking at, and they were the 3 that we tried to capture and model and assess. But again, a range there across, ranging from avalanche through to flood across our 4 types. As an example from that, this is from Nice. This is Natalia's work. So Natalia's been helping in our project. Thank you very much again for your brilliant work. This is for Nice. This was to look at the frequency, the co-occurrence of simply of two things, which was heat waves and droughts. And we know that to have a drought, you've got to have high temperatures. So there's a nice intuitive link between these two events. But quantifying them, of course, took a lot of work to understand when does one occur, when does the other occur, when do they both occur or not. And then trying to put the statistics in there, we're dealing with things that happen on different time scales, different spatial scales. That's all hidden behind what was a very nice, neat piece of work in the end, which produced some maps which show the co-occurrence frequency. From here, our next piece of work is then how do we package this up to then be useful to our stakeholders and our partners. But there's a side piece to this, which is in the rest of the project, this information now gets fed into the risk assessment process. It becomes split a little bit at this point. So the data that we've got here is already being used in other parts of the project. But in our work package, we're into the communication. I almost want to say social science a little bit at this point. Likewise in Essex, so here we looked at something a little bit different. We looked at combination of three things: high wind, temperature, rainfall. Those three things you wouldn't think would necessarily co-occur or wouldn't be of interest. But the basis as to why Essex County Council, that's a regional council, wanted to know about this is because they had very high temperatures followed by flash flooding. So this is more of a sequencing type of event. So you have one phenomena, very quickly switching to another phenomenon. Very challenging to model. But again, we come up with, well, in this case, 3 separate maps. But what we are now then trying to do is, well, how do we combine those into one meaningful statistic, one meaningful, usable number? And likewise, the final example I'll give here is Mullathing in Iceland, which is to do with landslides, heavy rain inducing landslides. Very different. But the benefit of looking at across these various places and the various hazard types, all with their own very real data and evidence limitations, enables us to look across this and then get some real cross-learning. So we're not just trying to fit one process, we're trying to say get a generalized approach together so it can be used. The next step of Mediate, say we're working on the indicator part, but then the rest of the project, that we're halfway through our 3 years, the rest of the project then moves more into the risk and vulnerability impact, and then into the decision support tool. And it's EU Centre that are looking after the decision support tool, so we're meeting them later to discuss it. The final thing I'm going to end on, and this is a project that I've not mentioned, this actually is a project that's just finished, but I wanted to bring it in here because, again, this is kind of part of the reason as to why Mediate ended up with the focus that it did, or perhaps why I'm working on the Mediate project. This was funded by a UK research council. It's called Emerge. And it's to do with emergent risks, so risks where in a changing climate hadn't really been too much of an issue, now are starting to become an issue. And multi-hazard as a theme ran all the way through this project. It's to do primarily with remote regions. It focused on Iceland, Norway, and Scotland, because they're kind of linked in a physical, weather, climate perspective. But it's to understand, well, how do hazards interact? And more importantly, is how will they change in the future, but with that particular remote focus. So here we've got 3 examples from each of the country. The first one is in Iceland. Well, of course, we've all seen on the news the volcanic eruption, which happened since the project finished. Like, we got in and out and did our workshops and stuff, so that's fine. But Iceland, floods in Norway, landslides, heavy rain and landslides. All of these have some combinations of more than one thing going on. So this was a theme that we ran through. We had a long debate about, well, what is remote in this piece of work, another definition issue, and realizing actually that I think there were, how can I say it? In Norway, the simple answer is, well, the whole country is remote. Other than Oslo, pretty much generalized, but pretty much most of the country would be classified as remote. In Iceland, there really wasn't a direct definition. So even this point of how do you define it? Are you in a remote region or not? Was questioned within the project, rightfully so, questioned within the project. In Scotland, again, we have a similar issue or similar questions we do in Norway. The majority of the cities are in what we call the central belt. That's where Glasgow and Edinburgh are, and a few other cities kind of tend to be dotted up on the east coast. But primarily, most of Scotland is pretty rural. But what we then did is then overlay across our study areas some key combinations of interactions between hazards that may not have been or you wouldn't naturally think these are the ones that these areas are most prone to. So here we are in Scotland. Remember I started earlier with it's a wet country where it rains a lot and water issues are not really a problem. Take the context of water scarcity that I showed earlier. Here we're looking at hot and dry conditions. This is not typical stuff for Scotland. This is the typical stuff for Scotland. But in the future climate, this is and will become far more of an issue. So this was the process we went through here in Scotland. And very pleasingly, it's this sort of information that we talk about impact, or earlier we're talking about policy relevant research. Here, that information is now being used to help guide the development of a new multi-hazard warning system for floods and droughts, to make that connection between the two in the Scottish context. So it's really nice to be able to be part of research that that thinking is being taken forward and being used in a real project. I think I'm about on time. I'm hoping I'm not overrunning too much. I mean, I can just conclude and say thanks very much, but I'll just say, for me, these are the things that I think we need to be thinking about, or where the gaps are. I've probably mentioned most of them already. Evidence and data is a key one. Unifying of methods, of course, is another. There are still some huge gaps and unknowns. The impact from multi-hazards, that quantification of, again, that question of why going from single to multi-hazard. I've given it a good stab as to why I think we need to be, but really rooting that in our processes and how we approach risk and the quantification of risk, and demonstrating, proving it is a big gap. Do we have the processes and mechanisms to do so? We've got some. But we need an awful lot more, and we need to stop bringing in more and more definitions. I've done a pretty good job at doing that myself. We definitely don't need any more. We need simplification, and there's lots of other things I could take away from there. I'm conscious of I'm talking, so I'm going to stop and say thanks very much. Thank you again, Marcello, for having me here. And if you have any questions, I'll be taken.
Thanks a lot. Thanks, Chris, for really overall overview of such complex problem. And I really appreciate many aspects that I want to highlight, but I would like to leave the floor to any questions. And yeah, sure. And then we can, I can even add minus. Right, just
I think I'll sit down for this part, if that's all right. Please, also, I'll just say I'm conscious we're overrunning probably by 15 minutes. If anyone needs to go and needs to get to, please do. Yeah, don't hold back just because I'm here. Sorry.
Thank you again for this great presentation. I just wanted to ask about the part about the indicators. You mean by that it's like intensity measures of the hazards? For example, can be bigger acceleration for earthquakes, or it's a combination of different hazards at the same time, and can be like a empirical indicator for two or more thermal hazards at the same time.
So do you want to answer?
The easy answer. We talked about this better in the last 48 hours. Chris will give you the answer.
I was hoping you were going to do that for me. Okay, in the context of what we're trying to achieve here in Mediate, we're using indicators to mean multi-hazard indicators, that is to take account of both the interaction between two hazards from an index, a computational perspective, but also then making it, I've used the words earlier of usable, so making it more of a communication tool or an output, some kind of graphical output that captures the interaction, but also retains some sort of usability attached to it. So, for example, on one of my slides earlier, I showed the climate stripes, University of Reading climate stripes, going from blue to red, which we can all kind of look at and probably fairly intuitively understand. At the highest level, what we're trying to do here, the first part, just as some examples, is come up with a set of metrics or indicators that would capture two things, not just one thing. Because the climate stripes are about temperature and how much temperature has increased relative to a point in time. I would like us to try and come up with some suggestions, some ideas about how we could do that, but for two variables. Two doesn't necessarily have to be hazards, but two interacting some things that could lead to something else.
So if you can add to your question, you were referring to specific intensive variables. So indicators are not that one, pretend to be something more, starting from those index and adding more value starting from that one. So it's more than just to be an intense hazard intensive.
Yeah. But if it's any consolation, so we have been debating that exact question for 48 hours. I think we've almost got there. But yeah, I wonder whether maybe we don't use the word indicator. Anyway, let's move on.
Maybe this one in my head yet. Thanks for the talk. It was very opening different avenues. Main point which I wanted to I saw those sites, and most of them are urban or city scale places. Many times these hazards interact at very different scales. How do you think this approach will scale up for events and situations which are happening at much bigger scales in terms of indicators and things?
It's a really good question, and I think you could take that way of thinking. You could keep going with that. You could go from a very small urban, say, city centre scale to say, well, that connects to something else. That then connects to this, and you could keep going, and before you know it, you're at the global, climate system sort of scale. I think with the work we're trying to do in Mediate, and the reason we're using test beds is obviously examples. So we can demonstrate a process, some calculations, some outputs in a way that cover a range of ideas. Where do we stop with indicators? If we get in our work right, in theory, they should be completely scalable, because the inputs to those, you could say, well, I want to put an input for this river system, or this city, or this location. But also they should be translatable enough, or transferable enough, I think perhaps is a better word. So if you wanted to do a countrywide indicator, how are, I know, droughts and the combination of droughts and heat wave changing over time, to be able to track them over time. You could do that on a country scale, or you could do it on a city scale. So I think you had indicator in your question. So I think for me, the answer is we need to get our indicators right so they're scalable and people can add their own information or thresholds or data to it, so it can translate. That's what we're trying to achieve. But again, it's going to be some examples, a demonstration of a way forward, I think. The other part, I'll just say it, which is, yes, I agree. I think in Mediate, we are quite urban, perhaps focused, perhaps with one example or separate example, which is Iceland, which is pretty rural, so a very small community, which is impacted by a few certain types of events, quite specific. So that has its own remote challenges. And as you've seen by the last project that I presented, the Emerge project, I have a particular interest actually in remote, because I think a lot of our thoughts and efforts often are where the greatest populations are, which is urban centres. But actually, I think that there's a really, if I can say it this way, a really interesting challenge of the contrast between urban and non-urban, rural in particular, because there's a coping capacity that goes probably higher maybe than urban centres, but then once it's reached, it's gone. And so there's unique challenges, and maybe the indicators need to reflect that as well. I would say that's outside the scope probably of what we're trying to achieve and mediate. But again, if we can get, say, things like the indicators right, then maybe it could be applied anywhere.
Conversation keep
From remote, someone wants to ask, just switch on the microphone. I see that in the room we have a lot of colleagues. I don't know if you have comments on but I mean, just to bring you on the discussion, because we come back to the definition many times. So
yeah, thank you very much for the talk. I'm from philosophy, so we like definition. We like to add more and more definitions. So, but I mean, I had a very general question about how the multi-risk story relates, especially in the climate case, with the representation of uncertainty. So, do you think that there is an interaction between the two? So, adding like a multi-risk like situation, either increase or decrease uncertainty. So, how would you like adapt uncertainty about the different causes of the different hazards into the final estimate? I don't know if it's clear.
Okay, I can answer perhaps. I'll say my answer perhaps in two ways. Firstly, I would say I'm still on, aren't I? I'm a bit more hazard than I am risk. So my answer is probably going to be a bit more hazard focused. You might be, you can perhaps add in from a risk perspective, right? It is uncertainty. It depends on where the uncertainty comes from. Is the uncertainty in the observations? Is the uncertainty in the models that we use and the future projections of those? I think when I think of uncertainty in this context, I'm probably more thinking about climate change uncertainty, as in the uncertainty that comes from the models. I think, but I recognise there's uncertainty that comes in at every step along the way here. Starting with observations, it's the work that we do in a multi-hazard space is only as good as the data we can access. And I highlighted, I think, with the MDAT database right at the beginning, which said we've got some data that shows something. I've been very genuine in that statement. But I recognise the limitations of such a database as MDAT. So right away there's a big source of uncertainty. And it could be that the numbers that I showed from that study in MDAT really underplay or overplay those relationships. Hard to know, because this is the only data we've got. The only way we're going to improve that uncertainty or reduce that uncertainty, of course, is to have better observations and better monitoring that relates these two or more things together. That's one part of it. Climate projections, I spent a number of years using downscaled, high-resolution, bias-corrected climate models. They're just representations of a possible future. They're just models, and they should be treated as just models. They're indicative, they're useful, but all have inherent uncertainties attached to them. So the range of what we produce has to capture that. How does that then overlay in a multi-hazard way? I don't think, I've not seen anyone try to quantify whether that increases, decreases. It's probably only going to increase the uncertainty. But, and the reason I have presented what I have done today in the way that I have is the concept of putting things together is the right way because it's real world. But maybe there's a real question in there, which is if we put these things together and model them from a hazard perspective, that is, how do we then reduce uncertainty? I don't think we've really grasped or even conceived of what the right questions would be to ask in that space.
Very interesting. So I have just a very more follow-up. I feel like I had the opposite intuition. So that maybe in some cases, even if you have like massive uncertainty about each one of these different phenomena, maybe you can actually end up decreasing the uncertainty just because you have. So in some cases, I think you like individually you might have the following situation. So you have all these different sources and have a massive uncertainty whether one or the other will occur, but seems like they kind of all showing a similar outcome in some sense. Well, in that case, even if I have like massive uncertainty about each one of those, like in the multi-hazard scenario, maybe my uncertainty might also decrease. So I also have this other in some cases it fails.
Well, like I said, I don't think we've well, personally, I've not really thought about that as a question, but it's an interesting philosophical question to explore. Maybe we should chat about that.
Sure, we don't have data to reply on the question so far.
Yeah.
So I didn't see any study that can justify an answer of the positive one. So we have no clue if it's increasing or decreasing at the hazard level. Then at the risk level, it's even worse. Because already with the one hazard, one exposure, one vulnerability, the uncertainty of the risk is driven by vulnerability or exposure, not by the hazard. So I can guess, actually, for a multi-risk will be again the vulnerability and the exposure, in particular if we consider future projections. It's not true that the climate, the climate future projection is uncertainty due to the model that we use. But if we talk exposure in 2100,
yeah.
If we talk about vulnerability of those exposure in 100 years, so then uncertain, and I think from a philosophical perspective, I don't remember if it was deep uncertainties. Yeah. That's I think it's exactly the term that when we deal on risk, that level that we're talking about, we are very far from quantified. I mean, if there are other comments, because I have one otherwise.
Regarding the gap in the research area, I've seen that let's say there are four main, let's say, subcategory of multi-hazard versus non-contact interaction. One of multivariate was the most studied one, but the multivariate itself, it contains concept of spatial and temporal. Why the temporal by itself is, say, underestimated and understudied compared to multivariate?
Sorry, so if I could paraphrase it, is your question, why do I think spatial temporal is less studied than multivariate?
Yes, because by itself, the multivariate energy concept of temporal and spatial.
It can be, yeah, I agree. I mean, I think I said when I introduced that to me, a lot of these terms are interchangeable. They're not meant to be exclusive. Yes, multivariate could be two things that occur at the same time, but in a different space. Technically, that could be a multivariate, it could be a spatial. But I think the majority of studies that we have looked at in reviews and pieces of work that we have done, majority of the time, multivariate tends to be two variables, two phenomena, two hazards, two something, same place, same time. Vast majority, not all, but the vast majority. So the other half of your question is why, therefore, has temporal or spatial not been studied as much? simply, I think from my perspective, is it's just harder to model. It's harder conceptually. The calculations are much more complicated because you're dealing with things that happen at different times to each other. In a spatial sense, it could also be that they're a little bit more linked either to the drivers that create those events, or they could be linked through the impact to things occurring in space, different spaces, that then cause an impact somewhere else. That's really hard to add data or information to in terms to be able to quantify. And I wonder whether part of that is driven, I think, by the research that is in this field, predominantly, not solely, but predominantly has come from meteorological, hydrological, climatological disciplines or subdisciplines. And I know that there's some spatial earth science, remote sensing people here, well, certainly within this group. But I wonder whether to tackle some of those more spatial interactions and spatial things, the information there is not really climate, or it's partial, but it's not really climate or weather data that's occurred at the same time. You need remote sense data. You need satellite information to be able to make these interplays and these interconnections. And so maybe it's simply, well, not just it's easier, it's also just a product of where has this discipline come from? Where has the growth in studies come from? It's come from one area. And in our discussions, I'm very much rooted in that side. But maybe then the opportunity is to bring in those other, let's say, non-traditional climatological disciplines and say, we need to be looking at this spatially. Temporal has its own challenges, all of its own. But from an interesting research question, the temporal spatial one, I think, is where we need to be going next along.
Just to give a couple of comments that came to my mind listening to your presentation. First of all, actually, it's quite funny. I'm not that a sport at all, but it's funny because you present a couple of works from Italian people. So the Silvia Solana and also the Gianluca Pescaroli about type of disaster risk interconnection. And you bring as a couple of examples of complexity, very already adding complexity and complexity. And then vice versa, you bring a couple of, you're showing these days, and the other one, the multi between brag hazard and risk from the world that are from North Europe. So I just don't mind this concept that as Italian we like to bring complex, because actually, probably you saw me this today that we want to bring complexity as well in the complexity. So it's a funny comment that I don't know if there is any causes effect behind that in English. So this is just a kind of joke way. It's funny when you propose two Italian papers works by them, done by them.
Can I just apologize therefore straight away? But yeah.
And then the second one is about the question why. Probably we need to rephrase a bit the question because it's not really why we need to tackle multi. Because the reason I think your presentation clearly give an answer. I mean, real world, real money are supporting this direction because the reality is there. So the answer to why is because the reality is there. So if we rephrase the question more like how we are tackling up to now, if we look at the index and the indicator of multi-hazard that we saw in the paper so far, are actually adding value, are actually helping to take decisions or not. In that sense, when we need to find our proposal, our suggestion indicators, we need to be careful and apply to these because the why is almost clear in the sense that why we need to solve it is because the reality calls for that. The solution that we provide are actually better than the single, they have the solution that treat the single hazard separately. And that's still not so. Because for sure there are money coming from World Bank, the European funding that are promoting this type of research. But I don't know if the replies as a researcher we are giving are actually adding value compared to the single approach, single answer, single risk approach.
Yeah, I won't necessarily try and answer that, but I agree. It's maybe it is the wrong question. Maybe we've already answered that question to some degree, and maybe it is more. What's the benefit that can come from it?
Exactly. Yeah. Exactly. What the benefit to from our solution compared to the previous one?
Yeah.
All right. Yeah, sure.
Thank you very much. Working.
And maybe another thing that we can do in a multi-risk perspective and talking about the interaction of different types of risk. Technological risk, for instance, and natural risk, not from this phase. And in that case, you are obliged to do this. So maybe this is another reason why we need to do that. And that's my questions. I was curious if in the projects that you mentioned, there was someone working on NATEC risk, this kind of things, because I suppose that almost always in that case, you have a kind of domino effect. So it's really a sequence of events, almost always. So just a curiosity. And that can be really another reason why we need to take this into risk perspective, because in that case, we are really, and it's a bit tricky in the sense, because when you just think about a single natural risk, then you say, okay, you can say there's always part of that risk that has some anthropic reason, some technological reason, even if we call natural risk. But then when we talk about NATEC risk, we say, okay, that's a natural risk, fully natural risk. This is a technological risk, but again, since I'm Italian, reality is much more complex, and then we have to redefine it with our intuition. So I was just curious about how your discourse can handle the issue of the NATEC risk. It's something that somehow may provide another reason to take this. And thank you for the presentation.
Thank you. And I think I can probably answer that question quite simply. Well, firstly, I agree. I think that there are multiple ways to, let's say, add justifications to why this needs to be done. The other side is, we've approached this very much from a hazard perspective, probably because of where our role is within the Mediate project, is that we're coming out from the hazard side. There is a component within the project that starts to look more at some of the cascades of impacts that could come from these events. And then very much then looks at the risk component, of which the NATEC and others could easily could fall within. It's not so much the area of the project that I want, or indeed my area of knowledge as such. But I would say on the cascade part, the cascading impacts, I think one thing that this project has very much highlighted, to me anyway, is that the complexities, there are enough complexities in what I have shown and presented here. The complexities that then happen when you start to come into the more human structures and societal structures and networks is another layer of complexity again. And I don't think in media we've necessarily addressed how do we do that all the way through. I think what we are doing is a quite a linear type of process, which has a to risk to decision. But I think therein is also then the opportunities to what we need to do next, which is look a bit more beyond just natural hazards and say, what about hazards in general, about risk in general? But perhaps that's not one for Mediate to try and tackle.
Great. Enough further question, comments. Again, thanks a lot. Thanks very much, Chris. That you were very solid.